Hello everyone, welcome to Mindspan Education. In this video, we are going to look at again the conditional universe. So the main idea of this video that we are going to look at few of the conditional quantity as an abstract object, right? It will make sense once I will start explaining the concept, right? Before that, you need to have a good understanding of the conditional universe. And if I say the conditional universe, what I mean is that you should have the understanding of the conditional PDF, PMF, conditional expectation, conditional variance, right? In both the cases, discrete as well as continuous random variable. And we have talked these conditional universe in each and every possible way. Right, we have discussed everything in terms of the event, we have discussed everything in terms of the random variable, single random variable, multiple random variable, right? So you need to be good with the notations, you need to be good with the concept, right? Once you are good with this conditional universe, then whatever the things that we are going to learn in this video, you will be good to go with. Before I start with this lecture, let me give you few updates that recently we have launched our GATE DA 2026 test series, right? And all the details will be available on the mindspaneducation.com. You can visit this website and you will have all the details that you need to have regarding this test series. Currently we are offering 25% of discount till 31st of July. So right now you will get the test series at 99999. Right? So enroll this test series before this offer goes off. Right? Otherwise this test series will be available it's on original price. Alright, and we have made the videos of launch, right? That is also available on our YouTube that you can go through and you will have all the details. Alright, now coming to our topic. So let me first of all start with recalling you the conditional expectation of this random variable x given another random variable y. Right? So what we are trying to find is the conditional expectation, right? And finding the conditional expectation is nothing. It is just like finding the ordinary expectation. Since we are in conditional universe, so what we are going to do while finding this conditional expectation, we are going to use the conditional PMF instead of the ordinary PMF. And we are going to sum this quantity over all the possible values of x, then you will have the conditional expectation of this random variable x given y. And let me also clarify that let me discuss each and everything in terms of the discrete random variable, and it will be also valid for the continuous random variable as well. You just need to replace this PMF into the PDF and you need to replace this summation sign into the integral. Right, so this is, we have already seen this conditional expectation of this random variable x given y. So we just need to use the conditional PMF and it is like finding the ordinary expectation, right? So we have this conditional expectation given this random variable y, right? So depending upon the value of the random variable that y it can take, right? So maybe y can take some value, y is equals to little y, right? Given this condition, I want to find the expectation of this random variable x, right? So you will have some numeric quantity here, you will find that some number, right? And depending upon the values that y can take, even we can find the expectation of this random variable x. Let's suppose we have conditioned over that y have taken some value that is y1, right? Again you will have some numerical quantity and so on. Depending upon the value of y, I can again find the expectation of this random variable x given that y have taken some value y2. Again you will have some numerical quantity here. So let me make you a point. Can I see this quantity as a random variable? And that random variable will be a function of y. Can I say, or can I define this, that g is a function of this random variable y, and it is equal to this quantity, the expectation of x given y. I can say it, right? So this will be a random variable or a function of random variable y, right? Depending upon the value of y, we will have different quantity. Since y is a random variable, so the function of this random variable will also be a random variable. We have already seen while discussing in the very first lecture of random variable, right? This y is a random variable, right? And depending upon the value of y, we will have this different quantity, different numeric value, or different expectation of this random variable x, right? So can we define a function of this random variable y, and it will be also a random variable, right? So the point is, here we are going to see this conditional expectation as an abstract object, and this is the abstract object, and this is a random variable again, right? And once we have this random variable, for this random variable we can have the PMF or PDF, whatever we can have. We can find the expectation of this random variable, we can find the variance of this random variable, whatever the operation we have seen about the random variable, we can perform each and every action, or we can find each and every quantity for this particular random variable. So let me conclude what we have done. We have seen this object as a random variable, right? And so I think this is very much clear to you. Now one point, let me ask you, if I say that here if I write the little y, right, that means that we are looking at a particular condition that y have taken the value little y, and we are trying to find the expectation of this. So this will be a numerical quantity, right? And if I write this, so I am writing in general that y can take any value that it's supposed to take. Y can take little y can take little y1, y can take little y2, right? So this is a random variable, and this is a whatever the value you will get after the calculation, right? So that is the one abstraction we have seen. What is the abstraction here? That we are trying to look at this conditional expectation of this random variable x given another random variable y as a random variable, right? And this random variable will be a function of this random variable y, right? I hope it is clear now, right? So this quantity will be let me first of all bring this to here. So this will be it is a function of y, and it is a random variable, and it will have the distribution. We can have the distribution of any random variable, right? We can find the mean of this random variable, we can find the variance of this random variable, and whatever the quantity or whatever the operation we can do on the random variable, we can do everything for this as well, right? So let me first of all now calculate the expected value of this random variable, right, or the mean of this random variable. right? So what we are trying to find is the expectation of this random variable, that is the function of this random variable y, right? And how we can find the expectation of a function? Using the expected value rule, right? So using the expected value rule, that would be equal to this function times the PMF of this random variable y. And the summation will go for over this y, right? So this is how we have written using expected value rule, right? And if you look at this, what is this? This is nothing but the expectation of x given y. So we can replace this function, that is g of y, as expected value of this random variable x given y times the probability PMF of this random variable y. Now if you have already following this lecture series, you must be able to recognize this quantity. What is this? What you are trying to do? You are trying to find the conditional expectation of this random variable y for each particular scenario, and you are weighting this conditional expectation to the corresponding probabilities of the scenarios. Are you able to recall what is this? So let me repeat one more time. What is this? So you are trying to find the expectation of this random variable x for each possible scenario, and you are summing over this quantity. So what is this? So this is the conditional expectation of each possible scenario, and this conditional expectation is getting weighted by the corresponding probabilities of scenario, and this thing you are summing for each possible scenario. What is this thing? This is nothing but the total expectation theorem, right? So you are trying to find the expectation of this random variable x for each possible scenario, and in order to find the total expectation of this random variable x, you need to also weight this conditional expectation with their corresponding scenarios, and you need to sum this thing over all the possible values of, or over all the possible scenario. So what is this thing? This thing is nothing but the total expectation theorem. So using this total expectation theorem, what is this? This is nothing but the expectation of this random variable x. And that is why I told you at the beginning of the lecture that you need to have, or you need to go through all the concepts that we have gone through, right? So using this, using the total expectation theorem. So if I have to rewrite this thing again, so how we can write is, so expectation, and this function g of y is nothing but the expectation of this random variable x given y, right? And that is equals to the expectation of this random variable x. So if you try to find the expectation of the conditional expectation, you will get a unconditional expectation, and this is referred as the law of iterated expectation, right? So this is also referred as, you can say, law of iterated expectation, right? So let me conclude this. We have seen this conditional expectation as a random function of random variable y, and once we have this random variable function of this random variable, we can find their distribution, their mean, their variance, and whatever the operation that we can perform. The very first quantity that we are interested in is the finding the mean of this random variable. And what we have found while finding the mean of this random variable, and this random variable is nothing but the conditional expectation of this random variable x. So we are trying to find the mean of this conditional expectation of this random variable x, and we have seen that the conditional expectation of this random variable x, the mean of this is the unconditional expectation of this random variable x, and this we have referred as a law of iterated expectation. I hope you are able to understand this concept. Now let me proceed further. Now let's suppose if I would have asked that what would be the expectation of the conditional variance. Would it be equal to unconditional variance? So in case of the expectation, if you are trying to find the expectation of the conditional expectation, then it is equal to unconditional expectation, and it is just the abstraction of this total expectation theorem, right? So what is this? This is nothing but the total expectation theorem, right? So in case of the expectation, if you are trying to find the expectation of the conditional expectation, we are getting unconditional expectation. Will it be true if I try to find the expectation of the conditional variance? Will it be unconditional variance? No, it will not, right? So let's try to look at that what kind of result that we will be getting, and our ultimate aim will be to express the total variance in terms of some, I don't know what it will turns out, right? Here how we have shown this total expectation like this. Similarly, we will try to show the total variance in terms of some, I don't know what terms will we will be getting, right? So what we are trying to find is the expectation of the conditional variance x given y. First, you need to be sure that this will be a random variable or a random function, right? Function of a random variable, right? It will be, right? So what is this? Let me first of all go through this variance. So what is the unconditional variance? So this unconditional variance of this random variable, if I ask x, that would be nothing but the expectation of the square distance from its mean. Expectation of the square distance from its mean, right? So this is what the definition of the variance, right? And if I ask you what will be the conditional variance of x given some another random variable y, right? So now we will be dealing everything in terms of the conditional universe, right? Now what we will, in order to find this conditional variance, we have already seen it, but let me repeat one more time. So we are trying to find the conditional variance of this random variable x. Now we will see the distance from its mean, and the mean would be the conditional mean, right? Because we are now in conditional universe, we will have fixed our universe, and within this we will see how far it is from the mean, and we will not just look at the mean but the square distance from the mean, and we will try to find the expectation of this. And we also have to indicate here that we are looking everything in the conditional universe, This is what the conditional variance of this random variable x given y, right? It what we are trying to measuring, we are trying to measuring the expectation of the square distance from the mean. The mean would be of the conditional PMF, right? So that is why we are using this conditional expectation. So square of that, and since we are in the conditional universe, so that is why we are trying to show here that given this random variable y, and I should not write here this that the y has taken some value that is equals to little y. Let me keep it in general. Y could take any value, that is y is equals to y, little y, y1, y2, whatever, right? So again, this variance, this conditional variance, depending upon this y, we will have the different variance of this random variable x. We can say that this will be a random variable, right? And it will be the function of random variable of this random variable y, right? So in this case, now what we are trying to find is the expectation of this random variable, right? And we have seen that it is not straightforward to write that the expectation of this conditional variance would be unconditional variance. We will have to see what kind of expression we will get, right? So the variance of this random variable x given y, that can be that we can write using the alternative formula as well, right? So if we have to talk in case of this, so what's the alternative formula of variance? It is the expectation of x square minus expectation of this random variable x ka whole square, right? So here if we have to write this conditional variance in terms of this formula, the alternative formula, we can write it will be equal to the expectation of this random variable x square given the random variable y minus the expectation of this random variable x given y ka whole square, right? Now take the expectation both side. So our goal is to find this term, right? So after taking the expectation both side, so using the linearity, we can have this term as the expectation times the expectation of x square given y minus the expectation of x given y, and here we should have whole square of it. Now recognize this, we have just learned what is this. This is the iterative expectation, and what we are trying to find, we are trying to find the expectation of this random variable x square given y, right? And we are trying to find, so this will be a random variable and we are trying to find the expectation of it, and it will be equal to the conditional expectation, sorry, unconditional expectation. So that would be equal to the expectation of this random variable x square. So what we have make use of total expectation theorem, or you can say the law of iterated expectation, that we have make use of, right? So here we are trying to find the conditional expectation. Sorry, let me repeat one more time. So we are trying to find the expectation of the conditional expectation, and that would be equal to the unconditional expectation minus this term, the expectation of x given y ka whole square. All right. So Still we have not achieved the expression that we should achieve, because what I am trying to say, or what I am trying to express, is the total the total variance, right? So variance of this random variable x. So here, this is the total expectation, right? So here we have got the terms, but we have no terms that includes the variance of this random variable x. So can we write this as the total variance? So in order to do that, what you need to have is, so variance of this random variable. So this is random variable, right? The expectation of x given y. This is random variable, right? Recall from here. So we can find the variance of this random variable, right? Using the alternative formula, what we can say, alternative formula of the variance, that means using this. Now instead, here the random variable is x, right? Now the random variable is this expectation of x given y. We can write, so this will be the expectation of the random variable chi square. So the random variable is this one, so iska square hoga minus the expectation of the random variable that is expected of x given y. So this is the random variable here, iska whole square. So I have used this formula, alternative formula of the expectation, right? And this quantity is a random variable, and here this quantity is a random variable, right? And we have these two equations. Let's call this equation 1 and call this equation 2. Now add equation 1 and equation 2. So we will have the expectation of the variance of expectation of this conditional variance x given y, that would be equal to, now if you observe, this term will get cancelled. If you add up, this term and this term will get cancelled, not this term, yes, this term and this term will get cancelled. And how we can write this? Using the iterative expectation rule. So what we are trying to find is the expectation of the conditional expectation, and that would be nothing but equal to the unconditional expectation, the expectation of this random variable x, right? And we will have this square here, right? So we are adding these two terms, so these two equation 1 plus 2. So here we will have on the right hand side plus variance of the conditional expectation of this random variable x given y, that is equal to the expectation of this random variable x ka whole square, right? Minus times will be there because here minus is also there, and on the right hand side we have this term also, so plus the sorry, this we have already written like this, so it doesn't went smooth, but let me write. So here we have written like this. Recognize this one. What is this? This is nothing but the variance of this random variable x, right? The expectation x square minus expected value of expectation of x ka whole square. This is nothing but the variance of this random variable x, right? So we have managed to write the total variance theorem, that is the variance of this random variable x, in terms of this. So we can write like this: the expectation of the variance of this random variable x given y plus the variance of this expectation of x given y. And if you look at these terms, what is this? This is nothing but the random function or random variable of a function of this random variable y, right? So this variance, so this term we can see it as a random variable, right? Similarly, this, the expectation or the conditional expectation, we can see it as a random variable. So here this what we have found is the total variance, right? Here what we have found is the total expectation, right? And we have written these in terms of the abstract manner. So this is nothing but the total expectation theorem, and this is nothing but the total variance, right? And we have written in the abstract way, right? So this total variance is the expectation of the conditional variance of this random variable x given y plus the variance of the conditional expectation of random variable x given y, right? So we have a way to write in more abstract way the total probability theorem and the total variance, right? So the first thing that we have seen is that if we try to find the expectation of this random variable x given y, and we have seen this as a random variable, and if we try to find the expectation or the mean of this random variable, then this is equal to the unconditional expectation, right? And we have also seen so here if you try to find this term, so that was the goal of finding that what will be the expectation of the conditional variance, right? Or what will be the expectation of this random variable. And it is not as straightforward as in case of the conditional expectation. We have few terms, right? So if you try to find this term, so this term will be equal to this minus this, right? So it is in case of the conditional variance, if you try to find the expectation of the conditional variance, it is not exactly how we have seen in case of the conditional expectation, right? So here so there are two learnings here, right? So we have seen that this, that is the expectation of this conditional variance, will have this kind of term, right? So let me write. So this is the total expectation theorem, and now the total variance that we can express is the variance of this random variable x, that is equal to the expectation of this random variable, that is the variance of x given y, that is the conditional variance, and we have seen this as a random variable, plus the variance of this random variable, that is the expectation of x given y, and we have also seen this term as a random variable, right? Let's try to look at a few examples. Let's look at this simple example. We have this random variable x, and it is piecewise uniform random variable, right? And what we are trying to find is the total expectation or the expectation of this random variable x and the variance of this random variable x. For this particular example, it is very easy to find without any having other kind of thinking. You can simply proceed with the formula and you can integrate it from 0 to 1, 1 divided by 2x dx plus 1 to 3, 1 divided by 4 x dx, and you will have the expectation of this random variable x. As well as you can use the formula of the variance to find the variance of this random variable x, right? But we might have the model that could be complex, right? Let's suppose if this kind of model, it is not complex, but just for the illustration I have taken a simple example. You can think of so what you can do first, you can divide your complex model into simple scenario, right? So I can divide this into simple scenario like this. So scenario 1, that is uniformly distributed from 0 to 1. Scenario 2, that is again uniformly distributed from 1 to 3, right? And then in order to find the total expectation, right, now I am saying the total expectation, total term is there, right? Because since I have divided into the scenario, now what I can do, so by finding the conditional expectation of this scenario and is this scenario, I can find the total expectation and as well as total variance, right? So the overall point is that if you have some complex model, you just need to simply divide those complex model into simple scenarios, right? And find the whatever things you are trying to find, maybe the total expectation of the complex model. So what you can do, find the expectation of each scenario, each simple model, and then use the total expectation theorem, right? Then you will have the total expectation of the complex model, right? And this we have already seen when we were dealing with the total probability theorem and total expectation theorem, right? And right now what we have seen is the law of total variance and the law of total expectation, and we saw that it is nothing but just a total expectation theorem in case of the total expectation, right? And we have also seen that it is nothing but this conditional expectation, and if you try to find the probability of this conditional expectation, sorry, the expectation of this conditional expectation, then you will have this unconditional expectation, right? And similarly we have also seen the law of total variance, and law of total variance, that is this, right? Let's try to go through this example. So can I define a random variable y, and this random variable y takes the value 1 when x is less than equals to 1, right? So x is less than equals to 1, that means we are considering this part. So I can say that whenever y takes the value that is equals to 1, then I am talking about this scenario, and in this particular condition this PDF is uniformly distributed, right? Originally uniformly distributed, and conditionally it will be also uniformly distributed. Now I can say that whenever random variable y takes the value 2, that is similar to saying that when random variable x is greater than is equals to 1 and less than equals to 3, right? So I have divided my complex model into simpler scenario. Next the goal is to find the total expectation of this random variable x. What I can do, I can find the expectation of the each scenario. So expectation when random variable takes the value 1, that means I am talking about this universe, right? And within this universe the unconditional probability is uniformly distributed, so the conditional probability will be also uniformly distributed between 0 and 1, right? So the expectation of this random variable 1 under given this condition, that would be by symmetry at the midpoint, so that would be 1 divided by 2, right? And the expectation of this random variable y given y is equals to 2. Now I am referring to this universe. We have conditioned over this universe, right? And we are trying to look at what's the expected value of x. Originally within this our probability was uniformly distributed. Conditionally it will be also uniformly distributed between 1 and 2. So what will be the expected value of x? The expected value of x in this case would be 2. What will be the probability of scenario first one, that is y takes the value 1, and what will be the scenario probability of scenario that random variable y takes the value 2? It is nothing but the area under this, right? So probability that y takes the value 1, that is equal to nothing but x is less than equals to 1, so that is the area under this, so that would be half, and this will be also half, right? So we are talking about this, so the probability of this is 1 divided by 4 into 2, so that is half, right? Now here is the catch. You can see this complete thing as a random variable. You can see, so how this complete thing can be seen as a random variable. How? Depending upon the value of y, right, this has some value. Depending upon the value of y, this has some value, right? And with this probability, so let me repeat one more time. Depending upon the value of this y, this will have the value 1 divided by 2 with the probability 1 divided by 2. Depending upon the value of y, this whole thing will have some value, and that is 2 with the probability 1 divided by 2. So this takes the value 1 divided by 2 with the probability 1 divided by 2, and this random variable takes the value with the 2 with the probability 1 divided by 2. So the point is, you can think of this as a random variable, function of random variable. And if I ask you the expected value of this random variable, so now this whole thing that I am writing that is in green is the I am trying to find the expectation of this random variable. And how do you find the expectation of random variable? So this random variable can take the value half and 2. So it can take the value half with the probability half, plus it can take the value 2 with the probability half. So overall we will have 1 divided by 4 plus 1, that is 5 divided by 4. Right? And we have seen, what is this? This is nothing but the same as expected value of this random variable x. You can try to find the directly using the formula of this random variable x, and you will see that you will find it will be 5 divided by 4. Now let's try to find this variance of this random variable x. So we are thinking this complete model as two different scenarios, right? So now we will be talking about the total variance of this random variable x, right? And just now we have seen that if we have the different scenario, that different disjoint scenarios, then the total variance is equal to the average of, or the expectation of, the variance of each scenario. So the average of the variance of each section or the scenario plus the total average, or the average of the the variance of the expectation of each scenario, right? This we have seen as a law of total variance, right? So we need to find the expectation. So what is this? This is again a random variable, right? So first of all, let me calculate this variance. So variance, this conditional variance, so variance of this random variable x, so variance of this random variable x given when y is 1, right? So that means we are within this conditional universe and the probability will be distributed uniformly, and we have seen the variance of the uniform distribution, that is the length square divided by 12. So here it will be 1 divided by 12, right? Or we can have find the variance of this random variable x when y takes the value 2. That means we are confined within this universe, and within this universe the probabilities will be uniformly distributed, right? So within this universe the variance would be the length square, that is 3 minus 1, that is 2, right? 2 chi square divided by 12, and that would be 4 divided by 12. Right? So you see, you can think of this as a random variable, right? So depending upon the y, we have different value. So this takes the value 1 divided by 12 with the probability 1 divided by 2, and this takes the value 4 divided by 12 with the probability 1 divided by 2, right? We can write like this, 1 divided by 3 also. So this you can treat as a random variable, and let's first try to find out the expectation of this random variable, right? What will be the expectation of this random variable? So it can take the value 1 divided by 12 with the probability 1 divided by 2, plus it can take the value 1 divided by 3 with the probability 1 divided by 2, right? So that would be 24, 1 divided by 24 plus 1 divided by 6. So that will be 24 and 5 divided by 24. Now we have to find this term, variance of this random variable. So this is what? This is again a random variable, right? Okay, let's try to find this term here. So how we can find? So we just need to find the variance of this random variable. And what's the random variable? Random variable is the conditional expectation of this random variable x given y. So using the definition of this variance, what is this? How we can find the variance of a random variable? It is nothing but the square distance from its mean. So now the random variable is this, right? So random variable is this, and its distance from the mean will be this term, right? So this is the random variable, and this term is the distance from its mean. So this is random variable and this is its mean, right? Expectation of this random variable, that is the mean of this random variable, right? And if you are trying to take the difference, this will give you the distance from the mean, and this chi-square expectation will give you the variance, right? And if you recognize this, what is this? This is nothing but the, using the iterative expectation, we can write this as the unconditional expectation, right? So overall, if you write, we are trying to find the expectation of this random variable, that is the expectation of x given y minus expectation of random variable x ka square, right? So if we treat this thing as a complete random variable, how do we find the expectation of that, right? So depending upon the value of y, so if y takes the value 1, so we are trying to find the overall the expectation of this, right? If y takes the value 1 and y takes the value 1 with the probability 1 divided by 2, and the if y takes the value 1, then this will have the probability, sorry, this will have the value, this will take the value, that is 1 divided by 2 minus expectation of x is 5 divided by 4 ka whole square, plus y can take the value 2 as well with the probability 1 divided by 2, then this will have the value, that is 2 minus the expectation of x is 5 divided by 4 ka whole square, right? And if you calculate this, what you will be getting is 9 divided by 16, right? You can calculate the further calculation and you will get this as 9 divided by 16. So this we have got as 9 divided by 16, and this we have got as 5 divided by 4. So the variance or the total variance, that would be 5 divided by 4 plus 9 divided by 16, and that will be not 5 divided by 24, here we have the 24, right? And that will be 37 divided by 48, right? So the variance of this random variable x is 37 divided by 48. And if you have gone through the simple without dividing this model into the scenarios, if you have gone through a normal calculation of the variance using the formula, you would have also get the same result, right? So we have just taken a different approach, right? So in this approach we have divided and conquer, and this is what the total expectation or the total variance is, right? So the total expectation what we have got is 5 divided by 4, and the total variance that we have got is 37 divided by 48. Alright, I think we have learned in this video about the law of total expectation and law of total variance. Thank you so much.